All right, Brent Breon.
Back.
Yeah, we are back finally.
The show's still going, guys. I want everybody to know the show's still going.
And we've actually videoed some.
Yes, we actually have some. We got some more dropping. We're about to start doing a bunch of remote shows. People just don't come through Houston as often in the big win space.
Yeah, it's true.
We're going to start cranking them out.
And we had the holidays in there. So that was kind of
weird.
And I was running around.
Living in tents and stuff. Yeah.
Freaking living on the beach, man. A city hippie. That's what I decided I am. So it's good. Nice. Love it. I actually been spending a lot of time in my camper.
Yeah.
Which I got booted off the other day. I went to I had left my camper out at a campground for a long time without a reservation. Nobody ever had a problem before, but apparently somebody ratted on me, and I got a call yesterday morning. I had to leave. I was at Nape, had to leave to go to North of Lake Conroe to pick up the camper and then come back down to Nape.
Just like a tow behind camper?
Yeah.
Okay.
Yeah. So I was, and you know how Wednesday night at Nape usually is. So
yeah,
early Thursday morning freaking trips like that are not fun, especially because, it sucks.
That's how I'm feeling right now, guys. This is the day after. This is the Friday after Nape.
So we apologize in advance to you, Brent, and to everybody
I might need
listening.
to apologize as well.
We may not be on our A game today. We're just gonna roll with it.
Yeah. But we're back, and we're gonna be getting a lot more episodes out here over the next quarter. We'll just be overloading everybody. So, but Brent, thank you for coming, man.
You bet.
We're excited that you're going to be one of the first 3 shows coming out after the new year.
Mm-hmm.
So,
nice.
It's Super Bowl week too, so I got my Chiefs hat ready.
Forgot that. Yeah,
excited. You guys, Chiefs
are gonna win.
All right.
I think Chiefs are going to win.
Think it's a psyop with Taylor Swift kind of deal.
It could be. It could be.
It might be. There's a tinfoil hat when we need it. I think it is.
Hey, if she was dating somebody on the Niners would win.
Yeah, I think so. But I'm a Chiefs guy though, Missouri. So let's go Chiefs. But
hopefully it's a good game.
It'd be a good one if the Chiefs win. I'm fine with it. So, but I don't care what the score is as long as they win. So, but on to the Brent stuff. So tell us a little bit about what you guys got going here with Pin Oak, and kind of tell us a little bit about your company, where you guys are at, what's going on, all the different stuff.
Sure. Yeah, so I'm Chief Commercial Officer at Pin Oak Energy Partners. I started in 2019. Prior to that, I had a pipeline background and pipeline experience. They brought me on Chief Commercial Officer. We had a number of wells that didn't have pipelines that we could get into production. So I spent, 2 years, 2019, 2020, trying to figure out how we can get that gas into production. We looked at CNG on pad location, trucking that off. Those economics didn't work. And ultimately ended up, I had some early conversations with Crusoe Energy back in 2019. They were getting gas at a very inexpensive price in the Bakken. So it was hard to convince somebody who's buying flare gas or getting flare gas
15 cents a penny.
Exactly.
I know they do one for a penny.
Yes.
'Cause I was there. But
so you look at just trying to put production equipment on the pad, you couldn't even pay for the production equipment.
Right.
But then luckily later in 2020, we had a group come to us and ask us about bringing one of those small upstream data generator, data center packages to a pad location and just buying gas off of us. And we had that, at that point, we had some plug or produce orders from the DEP.
Yeah.
And we said, well, this is new. The DEP wasn't sure about the operation, but he had an air permit, put the unit out at the pad and started producing gas from the pad, and got that well off of our plug or produce list.
What year was that?
This was 2020.
Okay.
Yeah,
all
late
right.
2020 into 2021. So we started looking around at other pad locations that we had that were stranded and didn't have any place to go. The next project we did was a joint venture project where we took gas that we had. We bought a generator. We operate 1,200 miles of pipeline as part of Pin Oak Midstream. So we have technicians that run Caterpillar compressors all over Pennsylvania and all over Ohio.
Nice.
So to hand them a Caterpillar generator, same front end, just a little bit different back end. So it was really easy to add my compressor technicians that maintain the compressors that, hey, we're going to add a 300 kW generator out here at the pad. We're going to take 80 MCF of gas from the pad that we can't get into the local distribution company because we can't meet their gas quality requirements. The pad at one point had a JT out there at the pad. And when you had higher pressures and higher volumes, the JT would be able to strip out enough of the heavies that you'd be able to meet the gas quality requirements. But as the well got older, and you didn't have enough pressure and enough contact time in a refrigeration unit either. You just couldn't meet the gas quality requirements.
Was this your first exposure to Bitcoin, or were you already orange pilled before this
No,
process?
this was my first exposure. My first
Okay.
exposure was just out of trying to find some place to be able to sell natural gas.
Yeah.
And so it was a solution.
Yeah.
Without me really fully understanding anything that was, behind the actual reasoning and everything that was Bitcoin.
What was your thought process then on when you looked at it, you're looking at CNG first, and like, okay, the economics don't work on that. Was there anything else you looked at in between CNG and then Bitcoin mining?
We looked at LNG as well.
Yeah.
Same problem as you just couldn't come up with. We looked at vehicle fueling, CNG vehicle fueling. These locations in the middle of nowhere.
Like nobody's driving out there.
Venango County in Pennsylvania, an hour away from Pittsburgh or more. I mean, there's no reason that anybody's going to drive to that pad.
You get a customer filling up at once every like 6 months. Some random dude, right?
Yeah. So there was very limited options out there for stranded wells, and that's why a number of those wells just end up getting plugged. And if you're a larger company like BP who came into Ohio and tried early on drilling the Utica and didn't have great success, a number of the wells that they drilled ended up getting plugged because they had the financial wherewithal to plug it. We bought a number of assets from Halcon, from Shell, from BP, all as PDP producing assets in the Utica Shale. And in order to get the deal done, you have to take a couple of these wells that don't have any pipeline.
Yeah.
And so you take those liabilities on and hope that you can find a way, or maybe natural gas prices go to $4 or $6, and now you can justify laying a pipeline.
Yeah.
But ultimately, the solution that came to us was the Bitcoin mining.
So when you thought about that, because this reminds me a little bit of Leachman, right, Ryan? When we started Jay, it was purely a necessity for why we started doing any mining. He didn't care at all about Bitcoin or any of that. But that was for oil production. This is, you're trying to monetize the actual gas. So did you have an issue with, like, what were your thoughts on Bitcoin when you got to that and you're like, well, we could monetize using Bitcoin?
It evolved from being almost a joke.
Yeah, right.
In the weekly operations calls, when I would give my commercial update on things that we were working on for these stranded pads, you'd get a big chuckle on the phone or a big chuckle in the conference room. Because at that point, we were all remote because it was during the pandemic.
Yeah.
And it would be a chuckle on it. Are we really looking at Bitcoin? I'm like, if the check clears and the guy's buying the gas and we can turn in the production information to the state, I don't care what he's doing with the gas. As long as it's legal, I don't care what he's doing with the gas.
How were you doing? Like, so in 2019 timeframe, right? Like, there weren't podcasts, there weren't events around this. Like, how are you knowing that this was even a tool in the first place?
So I had Eclipse Resources so prior to being at Pinhook Energy Partners, I was at Blue Racer Midstream, a pipeline company that was in the Utica Shale and in the Marcellus Shale building pipelines to the Utica wells. We were gathering the gas. We were processing the gas at the Natrium processing facility, at the burn processing facility. So I was super familiar with where everybody had drilled at, as I spent 8 years as a VP of business development trying to get as many processing and gathering contracts as I could. So I had a very good intimate knowledge as to where people were drilling and what they were doing. I totally lost track of what your question was there.
How did you know that Bitcoin mining was a tool in the first place? Were
okay.
you like on Twitter or were you like?
So Matt Dinezza was the chief financial officer at Eclipse Resources. And Eclipse Resources was one of the first customers that we at Blue Racer, acreage dedication and a gathering contract and processing agreement for. So I watched their development of the Utica Shale. Well, when Eclipse Resources was sold and merged with Blue Ridge Mountain Resources to create Montage, Matt Dinezza was no longer with the group. So LinkedIn message pops up that he ends up at Crusoe.
Right.
So I'm like, Matt's a great guy. I always, from a financial standpoint, he was fantastic. So I like to track where he was headed to and why he was going there. And when I looked at Crusoe, I was like, well, shit, people are actually, using stranded gas. So I reached out to Andrew at Crusoe and had the conversation with him. Like, hey,
I saw him yesterday.
Yeah, I saw him yesterday as well.
So long. He's a good dude.
And I said, so we had the conversation. Like, so what are you paying for this gas? Because if I can get enough to at least justify putting the production equipment in, I really don't care. I just want to be able to get a well into production. And then it was like 15 cents. And I was like, oh, shit, 15 cents is probably not going to cut it.
Right.
Like, but at least I know that the technology is out there.
Right.
So random inbound call from Mark Stevenson, who works with us now at Magellan Scientific. because his neighbor had a friend who had a Utica well on his property that Pinhook Energy Partners had.
Mhm.
He didn't even know if we had stranded assets, and called and said, "Hey, I'm looking for a place. I know this is going to sound crazy. I'm looking for a place where I can put a small upstream generator data set unit and mine Bitcoin on a pad." And because I'd had that conversation
"Oh, we
with
can do that."
Crusoe, like, okay, well, how much are you willing to pay for the gas?
Mhm.
I could probably pay $1, maybe $1.50.
Yeah.
I'm like, okay, I can justify putting in production equipment
Mhm.
for $1 or $1.50 as opposed to 15 cents.
Right.
So that's when I introduced it. And then I already told our team that looked at, tried Crusoe, but they're only going to give us 15 cents. So that's really not going to work. So we're like, well, let's give it a try. Let's put it out there. After he had his equipment up and operating on the pad and he was paying us, we're like, all right, this works.
Yeah.
And we got to be missing something.
Right.
Like there's got to be something
Yeah.
more to this. So that's when we started down, and Kyle Texter at that same point at Carbon Capture had reached out and was looking for the same thing. He had heard that we had been working with somebody else to do mining on pad. And that's where like, you know what? I don't think we want to just sell the gas at this point. Let's partner and try to understand what it takes to do all this Bitcoin mining on pad and make that next step. So when we partnered with Kyle, and like I said, I already had compressor technicians that could maintain the equipment.
Right.
We had spare cylinder heads for the generator that we bought. That was the exact same cylinder head that was on our compressor station at Lake Wilhelm compressor station. So it was really a good fit. And when we partnered with Kyle, he was bringing the data center out, and I said, well, let me know when you're coming out there. I'll put my boots on. I'll put my gloves on. I want to see everything it takes to connect the data center, to put all the computers in, to connect everything up, to get everything working on the site. And because I figured this is great. I'm a mechanical engineer by training. So I just love to do hands-on projects. And I was like, yeah, this is a great opportunity to be out in the field. Of course, it was in June. And it was hot as hell.
Yeah.
But yeah, we set everything up at the site, got the generator running. And then you're looking at F2 pool, and then you're looking at your wallet, and like, all right, we're making some Bitcoin here.
Yeah. That good for you guys though, for recognizing that. Cause they're still the majority of oil and gas companies, I think, are still like, if they're going to test it at all, it's like, we'll do a GPA and we'll sell some gas to you. But getting actually involved early on, is that 2020?
That was 2021.
Okay.
Yeah.
Right.
Late 2020, early 2021.
Yeah. And
it was shortly after that we said, all right, we've got all these stranded locations. We could potentially do 100 megawatts of power generation.
Wow.
On these stranded locations that we own and control.
Wow, that's crazy.
100 megawatts.
And we're like 100 megawatts times, and at this, early 2021, you're looking at Marathon, you're looking at Riot, you're looking at what their true exahash was, not necessarily what they had on order. I'm like, shit, man, you could have as much exahash as some of these main guys, and their stock price at that point is going through the doggone roof.
That was insane. Back when those first, like 21, when all the evaluations of the Bitcoin mining companies were just, it was insane. So
it was like what ballpark were we in?
Oh, like 25x multiples. It's insane. It's like crazy. Doesn't make any sense. And a lot of the stock, because you brought it up, was based on like orders that had been placed. A lot of the value on these stocks, it was completely out of whack. Like not realistic. And I obviously I'm a proponent of Bitcoin mining. I do think the public miners there's going to be there's a change right now actually happening in the valuation side of things, I think. But it's hard to maintain the market share of a network that's growing at the rate that the Bitcoin network is growing, for you to kind of maintain your place or your position in the overall scheme of, like, if I want to maintain a 4% share of the hash rate, the amount of capital that I've got to be putting in to keep up is, I don't know how sustainable that is. You know what I mean? So there's going to be more changes on those valuations on the public miners for sure. There's got to be.
I've always said that it's not in the best interest of an E&P to be a public company. I think you can operate more, I guess, efficiently as a private company. Do you feel the same thing on the mining side?
I do. My preference would always be like, just because we talked about this a little bit earlier, like even the private equity side, like just maintaining control of your company and what you want to do, and not being beholden to, an equity provider, or in that case, like public markets, because a lot of the stuff in the public market, it's not necessarily even based on just the baseline economic values. It's like ESG stuff, all the stuff you get dinged for different things that philosophically, we probably don't agree with a lot of the narrative on that. And a lot of it is not really to do with the basis of your operations or your economic value. It's like these ancillary things that, are philosophical differences. Like I'm not a big ESG guy. I think it's kind of a scheme, but I understand. I'm all about being environmentally friendly. Sure. Yeah. But like when that's such a big part of your valuation but from a public market standpoint, like,
well, that's the beauty of being a privately held company, to be able to go in a year's time frame from laughing on early phone calls that you're going to sell gas for Bitcoin mining to being, out trying to raise $6 to $8 million to buy data centers, to buy computers and to deploy 6 megawatts onto stranded pads that you have. And you are not going to, boards of directors to explain, all right, here's what Bitcoin is, starting from point one. Yeah. I mean, you get a couple leaders in the organization that understand commodities, understand energy, understand the space, and you can quickly make that leap to, all right, we've tried it here. We sold gas, it's working there. We joint ventured, we've got coin coming into our account every day. And so now we're gonna make that next step and try to take, $2 natural gas and turn it into $20 natural gas. And that meant a no-brainer. Of course, it takes like off-grid mining operation is the hardest mining operation that you can do. You've been there. Yeah. You know that for sure.
Trying to hit run times is tough.
It's tough.
Especially when you're talking about multiple locations off-grid. Yes. And it's like, man, and where's your source of gas? Is it one well? Well, that's always a problem too. You're going to have inevitable downtime. So yeah, it's not easy at all, but and you guys now, I mean, do you mind talking about kind of the shift? Yeah, because you got a perfect kind of comparison now, probably.
Yeah, and it is when Mark Stevenson and I have been, so we started deploying our equipment. We moved some of our equipment from off-grid location at an oil and gas, at a gas pad to an on-grid location in Ohio. And the reliability of power is crazy, isn't it? And Mark Stevenson, the first day that him and I showed up, we're starting to set up equipment. He's like, I know these PDUs are not going to trip anywhere near like they were in the field because they're getting good, clean, steady power. Right. And the generator's fluctuating and what power you're getting, and you're tripping the main breaker on a PDU. You've got 20 amps tripping all over the place.
Legs are getting out of balance. All stuff. I'm like,
and then you're like trying to look at the A, B, and C. Like, and I'm a mechanical engineer. I'm not an electrical engineer. And I'm like, well, you mean we got to load balance all this shit?
I've got to like turn computers off on this one to balance it out. Oh man, it's so much stuff going into it.
With you add in the complexities of a microturbine, because a microturbine can generate more power when it's cold and can generate less power when it's hot. So you take a fall, day in September in Ohio that goes up to 80 during the day and then goes down to, 40, 50 degrees at night. Now you have to set up foremen to sleep miners during the day so that you don't overload the generator as it can't make as much power. Because I mean, everything's on a shoestring, so you're not going to go rent a 1.3 megawatt generator when you only need a meg. You're going to try to rent a meg, and they can't even give you a meg when it gets hot out. Yeah. So you have to sleep miners, and then you have to bring them back on at night. And then you got to make sure, well, do I have them evenly sleep between A, B, and C phase? Because now you're overloading, trip a 300 or 600 amp breaker because you've overloaded one phase. Yeah.
This is like giving me old memories where I'm like, how is this working? And then we realized, well, we didn't mark on the racks which ones are going to A, B, and C. You know what I mean? And it's like, so then you're guessing, you're playing with it. You're literally watching, like, or when I turn off this rack, what's it do? And you're trying to literally balance it out. It can be a freaking, I mean, the learnings we did from like day one to the end was just like, it's crazy.
I'm glad that we early on adopted the Foreman software to be able to draw your racks and know where your computers were and flash them when you had an issue to be able to find things, because the early data centers that we did, we had numbers on all the computers. Right. And well, number 137 is saying there's a problem. I'm like, where the hell is 137, man? There's 90 computers in here. I'm trying to find. Then you find it and you're like, all right, where the hell's that power cord going? You're following it around. Oh shit, I tripped the breaker. Damn it. And you turn the breaker back on, and
it's fun though. It's like it's like one of those things where you're like, it's probably like by no stretch of the imagination am I trying to pretend it's the same I guess importance level, but it's like probably boot camp for like you look back and like, you remember we did that together, like we
We
need a
survived.
tattoo or something. Yeah,
The struggle.
yeah. But it was a lot of fun, and yeah, there is a lot of learnings. But you're no doubt, like I've been doing a lot. Most of the deals I do now are on grid stuff, and so you know, I like to stay involved and kind of see how things are going. And it's just from a complexity level, it's not even. I mean, I would sleep so much better at night knowing my stuff's on grid, just from an operational standpoint. Now, from the regulatory standpoint, that's where
that was the
on-grid
beauty
always makes
early
me
on,
nervous.
saying I could have 100 megawatts of
Right.
remote locations in Ohio, Pennsylvania that nobody would really even
Right.
hardly know that you're there. Now, there are definitely, depending on what townships you're in,
Mhm.
depending on, you have to have your permitting, you may have to have a building permit, you may have to have a special ordinance
Mhm.
to be able to be in those locations. But a lot of those remote locations, they don't have building code,
Mhm.
you know, they don't have any permit or any, variance requirements or any zoning at all.
And it's not as
And you were even luckier in Wyoming versus
right.
being in
Yeah,
Pennsylvania.
Wyoming's a wonderful place to operate.
Wild Wild
I'm a
West.
big Wyoming fan. Love that place. But
Yes.
you know, you also don't have the threat as much of the threat. You guys actually did have to deal with some regulatory threats, but you don't have as much of a threat from the government just coming in on the whole, you know, you're using too much electricity type of argument.
Correct.
Correct. So that's
And honestly, we would make the argument that we were helping the grid.
oh yeah,
Because we were doing this off grid
Yeah.
with computers that would have been plugged into the grid potentially
Right.
anyways.
right.
But now when you're looking at economic demand response and demand response opportunities in the grid, you're actually helping
You're
to
helping the grid
stabilize
there
the
too.
grid.
Right.
If you're making the decision that, all right, power prices just went to $278 per megawatt hour, I'm not mining,
Mhm.
and you shut off, and then all that power is able to go elsewhere.
Right.
So actually, you're really, in my opinion, you're stabilizing it and help the grid. And that's a good thing
right.
that Bitcoin miners are able to do
Right.
that.
And that's what do you guys think of and you don't have to answer if you want to, but like the EIA stuff. Have you saw that?
I saw that.
Yeah.
Yes. That's a quite exhaustive list.
Yeah. Yeah.
It's-
You guys will not reach that threshold where
What
you
is
No,
the?
we
Let's give some
won't.
context. What is the
Yes.
EIA?
yeah,
stuff?
so basically they're requiring any miners who are using I can't remember what the number
I don't
was.
remember exactly what the level
Right,
was.
but it's a fairly high level usage of electricity to report basically their usage, how much they're using, all this kind of stuff. I know some people are comparing it to other industries that are like, oh, they're having to report, you know, certain things, but it hasn't been reporting your electricity usage. A lot of it's been like what you're generating.
Yeah.
Those are different things to me because right now
I think they
the
were going to ask you
thresholds-
what type of equipment that you were
right,
using.
right.
They're
right.
asking you what
It's very
type of coin
detailed
that you were,
right.
what type of, whether a proof of work, proof of,
Right.
yeah,
Yeah, and
proof of stake.
I feel like it's definitely overreach, and I feel like it's very arbitrary.
This feels
kind of-
like registering firearms.
it does. It does. And in a way, because of the radical kind of aggressive anti-electricity or usage of anything other than a renewable, even though renewables are made from hydrocarbon products typically, even though you can be using electricity that's not going to make it to the grid.
Yeah.
A lot of the behind the meter stuff, which there is a lot of that as part of the network, and especially in the US, a lot of the stuff people are using is behind the meter, flexible load type projects. So it's not a fair or accurate read, even if you're reporting the electricity usage, because like a lot of this is stuff that is not even going to make it to the market ever.
Yep.
So I would argue
and
that
on
the
the flip
vast
side, you're
majority
making
of it-
you're making some projects economical by being
Right,
behind the
right.
behind the meter and actually providing additional income.
Yeah, that's the nuance that like it's so easy to say something. Look at how much electricity the Bitcoin network uses on a daily basis. They use more than this one. The reality is that you are generating revenue for projects that would not make it.
Yep.
They would not make it without mining. And those are the projects, the ones that the Bitcoin mining is actually making economic. Those are the ones that the people are going after Bitcoin mining would be proponents of.
Yeah.
And so it's either that they have that they're bad actors, they're acting in bad faith by trying to go after it.
Yep.
Because it's really like ideologically, it's actually supportive of their position, and it makes their projects they want viable.
Yep.
Or they just don't understand, and it's kind of a naive position for them to have, and actually one that is counter to what their stated agenda goals are. So, it's either hypocrisy or it's idiots.
Yeah.
It's one or the other. There's really no in between to me.
Yep. Well, that's probably a good transition
Mm-hmm.
to the stranded locations beyond just natural gas stranded locations that got Chris Halverson and myself at Magellan Scientific thinking about where else is there stranded opportunities.
Mm-hmm.
Can I take a data center to the Aleutian Islands? And can I mine off of, geothermal there? Can we go to Patagonia and put windmills? Where are there locations where there's tons of energy, but the market isn't there?
Right.
But you can bring a data center to those locations.
Mm-hmm.
And that's how we got into building the first turbo expander on a natural gas regulating station to be able to generate electricity from that process and then bring the data miner to the turbo expander in the middle of anywhere.
Yeah.
How much do you guys know about turbo expanders or pipeline operations?
Not much.
lot.
Let's go. What is a turbo expander? Let's start there.
So a turbo expander is a very sophisticated piece of equipment, but it's very simple.
Mm-hmm.
It is using a screw compressor, where typically a screw compressor would take a low pressure and then spin it up through the screws, kind of like a turbocharger or like a supercharger on a car.
Now you're speaking my language.
Make it into higher pressure and put it into a pipeline.
Okay.
Or you have air systems where they use screw compressors and create higher pressure air. You can take high pressure natural gas and run it through the screw compressor backwards. Goes in high pressure, comes out low pressure. And in the process, it's spinning those vanes that connects to a generator that generates electricity.
Okay. So is it more efficient to do it that way than?
Yes. So if you think about it, I have a prop.
All right. Perfect.
Okay,
Oh,
so
nice.
You have an oil and gas well in the field,
Mm-hmm.
a couple 1,000 pounds of pressure. If it's a shale well on there, you regulate that gas pressure down. It goes into a pipeline system, typically a gathering system, and then it gets to a compressor site. That compressor site aggregates a whole bunch of wells together and then puts it into an interstate pipeline. This could be in Wyoming.
Right.
There's no load in Wyoming. So that gas gets on a pipe there and then heads out towards Seattle and finds an end user out in Seattle that needs that gas. Well, you need all that high pressure. And a lot of times on those interstate pipeline systems, you have multiple compressor stations because the gas pressure will drop. And that's essentially boosting the gas to move it to a consumer. Every time you compress that gas, you're typically using natural gas and you're using energy to move that and to keep that pressure higher. Once that gas gets to a natural gas regulating station, all that energy that was put into that gas to move it across the pipeline is lost.
Okay.
Because you just take a regulator that's a simple valve and it just cuts the pressure, you have the temperature drop, and then the gas goes to an end user. So imagine taking a balloon. That's me compressing.
Okay.
And then you get to the regulating station and then you're slowly letting it out. I put effort into blowing the balloon up. And then all that effort that I put into it is gone once you let it out.
Right.
That's what's happening on the pipelines everywhere across the North America, everywhere across Europe, is that you're putting effort into getting that gas moved to the end user, because typically the end user is not right next to the well pad.
Yeah.
Especially if it's an industrial user, it's not typically right there. And then you're just giving that energy away. But if you take a turbo expander.
Problem
another
number 2.
prop.
Yes. Now, this might take me a second.
All right.
Because I haven't practiced this. You might have to cut this.
No, we're keeping this. This is great.
So I don't know how many.
That's the generator. Yeah.
Yeah.
That's the spinner in there is
Yeah.
making the noise. That's the same concept that is in a turbo expander.
That's the generator.
That is the generator. And so your air is, as it's coming through,
You're generating
it's
electricity.
reducing the pressure from one side to the other, and it's spinning, in this case, to make the whistle noise.
Right.
But in the turbo expander, it's spinning connected to an electric generator to make electricity.
we should be doing that everywhere.
So you're like, that's a great idea.
Yeah.
But where are natural gas regulating stations? They're typically
Rural.
not right next to power lines.
Right.
Typically not usually next to a user.
Mm-hmm.
So this technology is not new. It's been around for a long time.
It's just what are you going to do with that electricity?
Exactly.
Oh.
And so that was where we had our aha moment at Magellan, was like, I've known about turbo expanders forever. I've always thought the technology was neat. I worked at Dominion in 2003, and GE had turbo expanders that they had been manufacturing. They were using them at large, like LNG facilities. Because when you're taking liquefied natural gas and then regasifying and then cutting pressure, there's a ton of energy there.
Right.
And so they can capture that electricity and then use that electricity on site because they're powering all different types of equipment. But when you go out to a storage field in the middle of Ohio, where you're regulating gas from 1,600 pounds down to 400 pounds, you can generate a couple megawatts of power, but you're in the middle of nowhere. And once you start looking to take
I'm like
this
thinking
power,
about a bunch of stuff right now.
I know you are. Because you start thinking about, all right, I got to put a power line in, and then I've got to go to First Energy and try to get an interconnect on First Energy. And First Energy is like, I don't want your megawatt of power. I got enough other stuff that I'm trying to manage. Your interconnect's going to take a 3-year review. It's going to cost a ton of money in engineering. And then once you try stringing the power, the project goes from being essentially zero cost electricity to more cost than you would be able to sell it in the market.
You're compressing that gas constantly behind it. So it's probably a steady stream.
Well, you need to find a location that has a steady take.
Yeah.
A power plant is off of Rockies Express that's 1,400 pounds and taking gas in at 600 pounds and using 400 million a day of gas.
Wouldn't any well, and how fast? So I know this is just a balloon and a whistle, but like how much gas we talking to generate, say, 10 megawatts?
Great question.
Behind it.
The units that we're working with Annex Power is a manufacturer of small scale turbo expanders.
Okay.
And that's been the real challenge, is that at an LNG facility where you have tons of gas, you can afford a high CapEx and you can build a unit knowing that you're going to have a lot of gas for a long time to be able to pay for that unit. But most locations where you're regulating gas, 100 million a day, 50 million a day, 10 million a day. And so the challenge was for somebody to design a unit that's skid based, that's 8 feet or narrower, so you can ship it on a truck bed and you don't have to worry about a wide size load or anything. Drop it at a location on a skid. You don't need to worry about foundations. Get it set, connect it up to the pipe, and be able to take 10 million a day of gas and be able to make 250 kW.
Right.
Now, it's not a ton of power, but 10 million a day is a pretty small gas volume to run through a regulating station to feed a paper mill.
Could this not work at a midstream facility though?
Well, usually at the
Going
midstream
into the
facility, it could work at a well pad.
Okay.
Because the well pad, you're cutting high pressure to low pressure.
Okay, midstream already cut it.
Yes. Yeah. The hard part about a well pad, obviously you got contaminants, so you got to make sure that the gas is clean because you don't want sand, frac sand, water going through your turbo expander. But you also have declining volumes. And the best case scenario is to find a pipeline location where you have a regular pressure cut that's occurring from a high pressure line to a low pressure line and feeding continuously.
So maybe like a gas field.
Or take a Transco station that's in Pennsylvania or New York that's continuously feeding Con Ed natural gas 24/7, 365. Take any of those larger regulating stations that are taking gas that's drilled in the Marcellus, coming across northern Pennsylvania and being dropped in and consumed in the Northeast year round. Because you're never going to be able to build a turbo expander that's going to be able to handle the highest volume at the facility. You're going to build a turbo expander and install turbo expanders
for baseline.
For the baseline,
right?
But let me go a little bit further.
Yeah, because I got some questions, but yeah,
go ahead.
Well, what's it cost? What's it cost for a 250 kilowatt turbo expander?
The Annex turbo expanders are right around $1 million
for 250 kW.
It can actually do 500.
Okay.
For $1 million. And so the goal, obviously, with the first unit...
It's kind of expensive.
Exactly.
Yeah.
The goal, obviously, with the equipment is to be able to get to a point where you've got a modular unit that's the same build, every one, and you're building multiple units to be able to get that per unit cost down.
Right.
And so that has been our project with Annex Power, is to take the first unit that they've designed to be a commercial deployment of a unit and install that at a Pin Oak midstream regulating station that we own and operate in North Central PA. And then to be able to bring Magellan Scientific's data center to the site to be able to show a real location in real time where you are cutting the natural gas pressure, you're generating electricity, and you're mining Bitcoin off of that electricity.
Okay.
The economics of that location I'll readily admit will be a little challenging,
Mhm.
but it is a small enough project that as Magellan Scientific and as Pinhook and as Annex, we can put the money towards that project to
Mhm.
demonstrate the viability
Right.
of the equipment.
Right. Yeah, because the cost will come down.
Yes.
Right.
Yes. Now, taking it one step further, we are using an immersion data center
Mm.
combined with the turbo expander. And you're thinking, well, why are you spending more money on an
Yeah.
immersion data center? You're in North Central PA. It's not very hot
It's
up
not
there.
hot, yeah.
Well, the computers obviously create a ton of heat. The natural gas regulation process
Mhm.
goes from high pressure to low pressure, and you lose a ton of temperature. So most natural gas regulating stations upstream of the regulator have a gas-fired boiler.
Mm.
It
Mhm.
heats the gas up, typically from 50 degrees up to 100 or so
Mhm.
degrees, depending on how much pressure you're cutting. And then the gas flows through the regulator, and when it comes back out of the station, it's 40 to 50 degrees. It's
Mhm.
above freezing.
Mhm.
So you're using natural gas to heat up that gas stream.
Right.
There's scope 1 emissions
Yeah.
associated with burning that natural gas to heat that gas up. And then the computers are generating a ton of heat. So we're sitting back thinking, well, if you have an immersion data center with the computers and you're capturing that heat, and you bring that heat from the immersion data center through heat exchangers to the turbo expander and to the inlet, you can use the majority of the heat from the computers, get cooled down by the cold gas that's coming
Mhm.
in. It
You
raises
just
the
create a
temperature
full
on the
closed
gas,
loop cooling
and then
system.
it creates the heat that you need for the gas before it gets regulated. And you can, for the most part, eliminate burning natural gas
Mhm.
on the inlet of the regulating station. Well,
Mhm.
now you've helped to decarbonize the natural gas regulation process because you've got scope 1 emissions that you're
Mhm.
eliminating. And then through the generation of electricity at that site, you qualify for renewable energy credits that in Pennsylvania are tier 2 renewable energy credits
Mhm.
that you can sell to help pay for the economics of the project. Or if you're a pipeline company who has a goal by 2030 or by 2050 to be carbon neutral, you can retire those credits.
Yeah.
And it helps to offset your emissions elsewhere that you may not be able to
Mhm.
eliminate.
See, you're doing a good job of telling that story because that's the one to a lot of operators, oil and gas operators, that if they realize like they're going to be able to implement this and it checks all these boxes that they got to check, and at the same time man, you could use that a lot of places. I feel like,
Yes.
and get the cost down and scale up. Do you think I mean, obviously I think the generation capabilities will probably increase over time as well
They should. They
Right.
should. The estimates that we're using or that Annex Power is using for power generation are very conservative.
Mm-hmm.
So there, as we get this initial unit up and operating, we're hopeful that we'll be able to see more power generation
Mhm.
from it. It's created a little bit of challenge from a control standpoint because when you initially have the turbo expander starting up with the gas flow,
Mm-hmm.
you don't have the computers running.
Yeah. Yeah.
So you have to introduce an electric resistive heater that becomes essentially your load bank.
Mm.
You take the power from the turbo expander process, the power goes to that resistive heater. That provides the heat in your closed loop heating system that's feeding the gas until your computers come on. And then as your
Mhm.
computers come on,
You can.
the resistive heater is going to take less electricity because the computers are taking more electricity.
Mhm.
And then by having 40 computers sitting in immersion tanks and being able to overclock, underclock,
Mhm.
start and stop, you design control software that says, all right, based on flow, I need 220 kW of consumption. Turn these computers on. Okay, overclock these computers. Okay, flow slowed down. We only have 200 kW of power. Back the computers back down and be able to load follow so that you can
Yeah.
try to use as much of the power that's being
Mhm.
generated through just monitoring what is coming out of the turbo expander.
And I'm sure
This
you
is
guys.
some high speed low drag shit.
Yeah, dude. I like it. I'm like, I would love to know, and I know that I want to ask you the economics on it, but it's not. It doesn't look good right now. But it will.
So
I'm sure.
Back to your point. I mean, if you have 250 kW, if you do the math, if you have
Yeah.
S19s in there, you're making 6 Bitcoin a year.
Mm-hmm.
Is $250,000 a year enough to justify $1.5 million
$1
deployment?
No.
But pipeline companies aren't the same
Right.
as
Yeah.
privately held companies. They have monopolies in areas. They have rate structures that are designed for the good of everybody that they serve.
Mm-hmm.
And what sometimes doesn't make business sense in a normal publicly traded company or a privately held company, can make a lot of sense for the pipeline companies.
Right. That's a whole different model, and like it's another way to start generating some revenue on something they already have and it's already coming in.
So the pipeline companies, they deploy capital,
Right.
they build pipelines, and then they make a rate of return, and an agreed to allowable rate of return based on their tariffs. Especially in the Northeast, you can't build pipelines anymore.
Right.
So what most of the pipeline companies are doing now is modernization projects. They're going and replacing old compression that leaks methane into the air because it wasn't designed for a capture system that captures that methane, and they are putting in new compression that has it's emission free. They're putting in heat recovery systems on the exhaust of those units because they can create electricity from those heat recovery systems. In a lot of cases, they're just eliminating natural gas fired compression altogether and converting everything over to electric in order to eliminate the emissions.
So there's a lot of substations being built?
There's a number of stations that are being replaced through modernization projects. You have 1950s, Clark compressor units out there that are needed to be replaced anyways.
Yeah.
But under the argument of modernization and decarbonization, you're able to take that CapEx, put it into your rate base. If I can't build pipelines, but I can replace compressor stations and modernize and eliminate emissions, then that's good for the public and that's good for our investors. If you think of a regulating station that's been built 30, 40, 50 years ago, that's wasting all of this energy, it's a great opportunity for modernization and decarbonization as well. So if the pipeline companies are able to take turbo expanders and install them as a modernization project to be able to take an old and inefficient technology of regulator valves and instead put in a turbo expander that can also generate electricity and also tied to a data center can provide a reduction in the natural gas that's used on the front end. Now you may be able to make an argument to your regulators that this is a modernization and decarbonization project that, oh, by the way, has an electrical component that I sell, and it has renewable energy credits that I can use to offset my footprint elsewhere. So it's good for our pipeline operation. It helps us meet our decarbonization goals. And I'm willing as a pipeline operator to spend the money to build the regulating station because I would like to get my fair 8, 10, 12% rate of return that's agreed to in our rates.
And if they're already going through that process, why not like the modernization?
Because they're going to run out of compressor stations that they can replace. They're going to run out of locations where they can put in solar panels and be able to try to power electric compression. And so then and that's the low hanging fruit that they're doing right now. What are the next things that they can do? And they have thousands of regulating stations where they deliver gas to the LDCs. The LDCs have thousands of regulator stations where they're delivering to end users. So there's plenty of opportunity to be able to look at, all right, let's modernize how we regulate natural gas delivery to our customers.
I freaking like it. That's cool. That's really cool. So did they give you an idea on the forecast on like cost reduction? Or do they think they...
No, we're still in the early stages. They are in the same position where they need to be able to take it from development into actual production. Yes.
Okay.
Yes.
Because I could see that making a lot of sense, man.
The hamster's running up there.
I know. I'm like, golly, I think that it'd be fun too.
So one of the things that we did really early on, as well as Magellan, is we were working on this concept. We said, all right, we need to reach out to a patent attorney. We need to see if somebody else is already doing this, number one, or has a patent for this. And after some pretty exhaustive work, we determined that there was some turbo expanders with data centers. There were turbo expanders, but nothing that had this real process. So in 2021, we filed for a patent application.
Okay.
And last summer, we received our patent from the U.S. Patent and Trademark Office.
Congrats.
So we had 22 claims. All 22 claims were approved in the patent application.
That's nice.
So we do have now IP protection for the process as well.
Yeah, I was kind of surprised you brought in the whole demonstration and all that. It was like, man, this dude's giving away some secret sauce here.
He's got it locked down, man.
Well, now I know. Yeah, that makes sense. I like it. I could see that being something that really grows. Why would you not do it?
I think it's a good combination of data centers. It really, whether it's Bitcoin mining or whether it's company blockchain specific applications, whether it's artificial intelligence, I think it's a good opportunity to take stranded energy from a turbo expander that wouldn't otherwise be able to be used, and then combine that with your heat recovery and be able to make the argument. And it doesn't have to be turbo expander, data center. it can be all just one skid, and it can be all one big package. That it just provides electricity that's used for reheat, but it also provides electricity that can actually do work.
Right.
Because in the simplest of approaches, you could just take a turbo expander and a resistive heater and just be able to use that to be able to run it. But why would you waste the electricity?
Right.
Use the electricity to do computer work, and these computers are so efficient at their consumption and then the heat that they create from that you have almost a 1-for-1 of the power that's created, and then the BTUs that are returned through the dielectric fluid and in the immersion data center back into the natural gas stream.
That's another reason that I think the whole attack on Bitcoin and synergy, there's so many ways to innovate.
Yes.
And touch on so many different businesses. And a lot of it comes back to the type of innovation should be the type that it is the type of innovation that a lot of these people that are attacking it would be proponents of.
Yeah.
And it's there. I don't even know how many examples we could bring.
There's a lot.
There's a ton.
How big of the market for this application is?
Oh, there's thousands and thousands of locations just in the U.S.
That's huge.
I mean, if you think about every house that is fed natural gas, at some point that gas went through a natural gas regulating station. If you think about every power plant that's taking gas, and they use a ton of natural gas at power plants, natural gas fired power plant, they're all typically taking a couple 100-pound cut off of an interstate pipeline into the facilities. And so there's thousands of locations. The equipment is installed parallel to the existing natural gas regulator run, and it's designed to operate. And if it fails, the gas will flow back through the existing natural gas regulating run. So you're not replacing necessarily equipment. You're adding another layer of the same equipment that provides redundancy at the location as well.
What pressure does it have to come in at?
The units that Annex is manufacturing can handle up to 1,440 pounds.
Okay.
So I like the design that they have because it can handle that higher interstate pressure. You need usually a 2-to-1 to 3-to-1 pressure reduction ratio.
Man, so that's like a trucking terminal. You like, we like where we were at. It was coming in at 1,000 pounds, and we're dropping down to at the site on that site at you're going in the gen sets at like 3.
Yep.
3 to 5.
Yep.
So, and we had a big drop from freaking, I think it was 1,000 to like in the our little shed to like 250, just in a short distance. In fact, it would freeze up sometimes. It's too short, but I mean, you could put one out there, and that was just one location, right? When we got 2 million a day coming in at. So
I think there's a long-term opportunity as they develop this equipment to be able to build a higher pressure unit that is able to be truck mounted and able to brought to a shell pad and used. I mean, you're gonna have to have a good sand trap and everything else, but to provide electricity on pad.
Yeah, well, that's what I was just thinking.
Then that electricity on pad
won't need generators out there.
No, then you don't need your air compressors to be able to provide the air that you need, because most of those new pads are not natural gas controlled pneumatics. It's air driven pneumatics. Well, they need electricity or they need a generator to be able to have the air driven pneumatics. If you have a turbo expander that's part of your regulation process on pad, then you use that electricity to run your pneumatic. What would have been your pneumatic controls now with air? Yeah, or air.
I could see it being a home run. It's obviously it sounds early, but you guys got a patent. That's what you just build on it.
And that's really our goal. We're going to get this first location in North Central PA up and operating.
When do you think that'll?
We have the equipment being delivered back out there on March 15th.
Oh, so this is like imminent.
Yes.
Man, I wish you go see it.
We should.
Yeah, I'd love to take you guys on a tour of it.
Yeah.
And obviously because of the unit being controlled remotely through SCADA controls, the data center being controlled remotely through SCADA controls, we'd be able to sit down even if the unit was operating right now and bring up the computer screen and be able to show you, here's how much power we're making, here's how much mining operation, here's what we're generating, and all be able to see because it's all remotely controlled as well.
I think it's pretty dope. That's cool. That is really cool. So, man, I didn't expect that.
No, we had a call a while back, and I was like, "This is super cool." I was like, "We have to get you on the podcast."
I keep wanting to call it a turbocharger.
I don't know why. It's like early on I said turbocharger. I should have said supercharger.
It keeps wanting to come out, but turbo expander. I'm gonna be doing some freaking.
They also go by the name of gas letdown generators. Gas letdown generator is probably a better description because it's gas pressure let down and it generates.
Turbo expander
The
sounds
turbo
cooler.
expander sounds
yeah.
cooler.
Yeah, that does sound cooler. That does sound like something to be in a car
Yeah, it does.
that you would be driving.
That I would be driving for
Yeah.
sure.
Yeah, it definitely does. But yeah, I mean, obviously, expense for that right now would be high for a miner, but you're right. Like a lot of other use cases that miners could then use it for. So I freaking like it, man. I like it. We should go out there and
We should. I love it out there.
do
I'd
a
love to take
field
you guys
shoot.
out there, take a field trip,
Yeah.
take a
Yeah.
look at the unit.
Yeah.
Let's make that happen.
Well, so what are you guys' expansion ideas, if you have any, on? Are you still going to look at monetizing that stranded gas?
We are.
Through
We still have one pad location that's
Yeah.
not connected to a pipeline network,
Mhm.
and so we are still mining at that location. And even if the economics become somewhat marginal, it's
Mhm.
best to still be able to produce that location
Mm-hmm.
with the mining operation. We're kind of on a pause right now.
Yeah.
April's coming very quickly,
Yeah.
and
Right.
we're gonna, as we've got this on grid location operating now,
Mhm.
and trying to get to a point where we're qualified to be able to participate in economic demand response. We'll see
Mhm.
what happens in April with the halving, what happens with hash price, and then we'll hopefully pivot from there to
Yeah.
try to expand.
It's funny because you said you started and it wasn't really about Bitcoin or anything. But you sound like a Bitcoiner now.
It's amazing the amount of podcasts that I listen. When you have I did a lot of work at the remote locations with the team,
Mhm.
and when you're driving 3 hours in the middle of nowhere, you can listen to a lot of Bitcoin
Yeah.
podcasts.
Hopefully this
I
one
have been
too,
completely
right?
orange pilled at this point.
Oh,
Yes,
good.
yes,
Yeah.
yes.
It's funny how that happens. Like, I mean, Leachman became a huge maxi after we got going. It was a short period of time where I was like, dang, dude, you went from like zero to hero
Yeah.
real fast on your Bitcoin beliefs. But yeah, it happens a lot of times. So I don't, once you get into it, it's kind of hard to get away from it.
Nobody leaves Bitcoin.
No.
No, and I think that, and I like some of the things that Michael Saylor has to say about Bitcoin really being energy
Mhm.
and
Right.
being the perfect battery are some of the things from a mechanical engineer and from a field operations standpoint that I look at, because the gas is stuck in the ground. It's essentially stored in the ground if you can't get it out of the ground. But if you can get it out of the ground, you can turn it into something that you can move easily. It's the best solution.
Mhm.
I mean, hell, I'd rather have everything be in Bitcoin than have it in natural gas, because then I don't need compressors. I don't need pipelines.
Right.
I don't need anything. But
Yeah.
it is very convenient to
Mhm.
take an asset that's very hard to move from point A to point B as natural gas and to turn it into something that I can send you,
That's
via-
a really good point. Like how hard it is to actually get gas to market. There's a shit ton of stuff that goes into that.
Yes.
And you're right. Just having a Bitcoin mine is the easiest way to monetize something that's that hard to
Yeah.
move. That's
Yeah.
a really good point. I described it that way. I like it.
Brent, this was awesome, man.
Yeah, I
this
appreciate the
was.
opportunity to
This was
share
great.
what we're working on.
I think you're gonna blow a lot of people's minds, so I can't wait to release.
I know.
this.
Yeah, I'm excited. That is really cool. I had not heard of that. It makes total sense. Great illustration with
Your first
the
guy to
whistle.
bring a prop.
yeah. First prop. We did get a prop last Empower.
Oh, we did the tinfoil
Tinfoil
hat.
hats.
Yeah, we got to
So-
bring that back.
Yeah, we do. But yeah, man, great illustration, and yeah, I'm excited to release this one too. You guys are gonna kill it with that, man.
I hope so.
It might
I
be a
hope
few
so.
years, but
It's one of those, we were working short term on our off grid locations and then our on grid locations, and this is one of the ones we've always had in the background. Like you said, it's an investment. It's going to take some time to hopefully realize, but we really believe in the technology.
that I mean, short period of time that we've talked about it sounds incredible. It could have a lot of applications for a lot of different things you're probably not even thinking of right now too.
Yep.
So
Yep.
Because I'd imagine there's other use cases where a turbocharger,
Well, there's
turbo expander.
I
would
will
be
tell you that there,
used,
you could use that same turbo expander to put an electrolyzer
right.
and generate hydrogen
And
and put the hydrogen into the pipeline.
hmm
Now, the economics aren't there,
right.
but the economics are kind of tight on this as well. But there's other things that you can do that are
Right.
unique and that are clean energy related.
hmm I like it. So thank you for
Yeah.
sharing that on here.
You bet.
So well,
This is awesome, man.
This was awesome.
I'm super excited about it.
We got some more shows coming up, but thank you, Brent, for coming. Thank you for sharing that. Yeah, man.
We need to go up to PA.
yeah, let us know
make a
when.
trip out. I love it
Summertime.
up there.
Much
We could-
better.
we could
Yeah,
do
let's do it. Yeah, definitely something.
Yeah, we should do another little mini documentary.
Let's do it.
Make a whole one on like all kinds of the different new innovative, energy ideas. that
We did.
people are coming up
We're
with.
finishing up on CNX right now.
Oh, yeah.
Yeah, releasing it
Nice.
this week.
Nice.
So it's gonna be awesome.
So,
Very cool.
Well, thank you, Brent.
Yeah,
Appreciate it, man.
Yep.
Yeah. Good seeing you. Guys, share the episodes. Like, subscribe.
Yes.
The whole 9 yards. We are back, baby. We're gonna be
back.
cranking these things out.
Yeah, we're gonna load up now. My life has settled in very nicely, so I'm ready to freaking go to work.